Ladies and gentlemen, it's good to connect with you all again. And today we have an opportunity to introduce you to Dr. Justin Sutherland, who is the co-founder and CEO of Realize Medical, which is one of the companies who are actually offering solutions in 3D visualization, very specifically AR and VR. And a company who has really been working in the medical space and been offering some great value add for doctors and surgeons to make the surgery more convenient and easy, because it's so important that you need to plan your surgeries before in hand. We all believe in a process where in the OT it becomes very difficult for the doctors to otherwise operate without having a planned kind of a module. So here is something that AR and VR is actually offering. At the same time, we also understand that in the trading space, there is a lot of gap that needs to be filled, what AR and VR can do. So I'm sure with the technology growing and the technology gaining that kind of attraction globally, Realize Medical is actually understood the prospect and also working towards it in terms of also being a research-based platform to have been able to work in that direction. So today I have the opportunity to introduce you to Dr. Justin Sutherland. Doctor, a very good evening here in India and also back in Canada. It's a morning. It's an afternoon.
Morning. Yeah.
Yeah, good morning. Yeah, so good to see you, Doctor. It's been some time. We did have an opportunity for you to also participate in our 3D Graphy workshop last on AR and VR. And thanks for your time, Doctor. Yeah, just wanted to understand and know where it all started. How was your first interaction? We would want to know the story. Where it all started with your background. Sure. To begin. Yeah, please. Thank you.
So. Thank you very much for having me. I'm a medical physicist, which even in the medical space, a lot of people aren't quite familiar with. That medical physicists are physicists who work in hospitals, and they're primarily responsible for implementing and running new technology in a safe and accurate way. So it really relates to radiation and other physical properties and their application to medicine. So treatment of cancer with radiation, MRIs, CT scans, X-rays, ultrasounds. All those things have physicists involved to make sure that the processes are running properly. And actually, those technologies come from the domain of medical physics. So as a physicist at the Ottawa Hospital, when the new commercial virtual reality headsets first started coming out, I had an interest in that just from my own leisure time of playing video games. And I brought the technology into my department just to give a demonstration to the types of things that it's able to do. And then I suggested that this could be something that we do for research. So myself and a few colleagues actually spent over a year just developing different things and trying to just play around with how the technology can be used to interact with medical image information in new ways. So in radiation treatment planning, we take a CT scan of the patient every time they're going to be getting a new treatment. And so we wanted to look at, okay, can we interact with these images in different ways? Kind of answering the question, how does Superman do X-ray vision? So like you watch the movies and someone will be hurt and Superman will look at them and he can just naturally peer through to see the various organs and find out what's wrong. With virtual reality, you can kind of almost create any experience that you can imagine. And so if we were to do that in practice, what does it actually look like? Obviously, we can't just like snap our fingers and see exactly what we want to see. We have to be interpreting the medical image information in some way. And so our company came out of one of these experiments, primarily where we stumbled on the idea that virtual reality is not just a medium for consuming 3D content, but it can actually be a medium for creating that content as well. So for any of your viewers that are interested in the process of segmentation, which is the first step for 3D printing or making digital models to use in virtual reality, you're painstakingly delineating portions of an image so that you can define some anatomical feature or organ, right? And that takes a lot of time. And primarily, we figured that one of the reasons why it's so laborious is because the format that you have to interact with the system is limited. So if you think about it, you're looking at a computer screen, you're seeing slices of images. Maybe if it's 3D, it's there, but you don't actually perceive it in 3D. And then your interaction with it is often just a keyboard and mouse where you're moving up and down and left and right and clicking. With virtual reality, we have this full 3D environment around us, right? And you can reach out and do things with tools and rotate things with your hands and peer around them. And so we figured it was just a much more compatible environment for that type of activity. And that's really where the company got started, was with that idea.
Very interesting, Doctor. Doctor, one more thing that I would probably want to understand now. This is actually in the actual OT room that you can also use it, or is it actually pre-op when you plan the surgery? So you can do it on the table of when the surgery is done.
No, so the basically what we've built is a tool that lets you import medical images and then create 3D structures of the kind that you might 3D print, and then interact with them in different ways, pull them apart, cut them away, make markings around them, that type of thing. So it's not something that's at this moment used in the surgical room. Okay. Largely, the reason for that is because we've used virtual reality as the technology for this platform. When you're doing stuff in the operating room, you need to be able to see the real world, obviously. And then in that sense, augmented reality is a solution that's more suited to that in terms of technology. One of the downsides of augmented reality, particularly the ones that you'd really want to use in the OR, where you see the real world through a visor and then virtual elements are overlaid on top of that. The downside of that is that it can't produce really high contrast images. So like no deep blacks. You can make bright things, but you can't make it darker because you're just adding light to what you already see. The core of our platform is the model creation aspect of it, and then the interactions that you can have with those models. And so that relies on interpreting and interacting with these medical images like CTs and MRIs. In that sense, you do need the high contrast resolution. And so the virtual reality as a technology is better suited to that activity just because you're cutting out all the light from the real world and you can make things as dark or bright as you want.
Yeah. So typically, this technology would be more useful for all surgeons in all the medical practice or specialization, doctor. When I see neuro, yes, this is going to be really, really benefiting in terms of getting there to the T in terms of what is expected. Even cardiology, we already have Dr. Mahesh, who is a fan of the technology and also one of your respondents. So I'm just trying to understand in terms of where all it can be utilized. The reason why I'm asking this is, Doctor, we've also now setting up 3D Graphy labs in the country. Now that's another initiative. So we are setting up these centers of experience for doctors and patients both coming and experiencing the process. So it's something that is very, globally it is also a good practice being already there. But in India, we are still seeing an opportunity there in terms of, having a patient satisfactory index is very, very important, doctor. So it is also important for the patient also to know how and what is the process of his operative surgery, because it's his body. So he also needs to know, what is it going to be when he's going to be in the table, because in the OT. So I think that is an interaction method that we also believe in, and we would want to start this. And with your solution, I'm very, very keen in terms of taking this course forward. And there are some of the doctors from various specialization that we are also signing up to see that, how we can build that particular channel and the initiative. Yeah, your take on it.
Yeah, so the technology has broad application to many different medical specialties. So we have people who are in orthopedic surgery, neuro, radiology, radiation oncology, cardiology, all sorts of different things that you could think of. Basically anything where you would see a benefit from 3D printing, you could see a benefit from using virtual reality. I happen to believe that the use case for virtual reality actually broadens with respect to compared to 3D printing. And one of the reasons for that is because the commitment to doing the activity is lower, right? If you have the system in place, it's just a matter of quickly creating the 3D models and then popping on a headset, right? Versus having to take the time that the printer's going to, using that printer time and the materials to create something, you might not get, it's basically like an equation for cost and benefit, right? And then if the cost is lower in terms of the time it takes to do it and then the resources required, well, then you don't need as quite a high benefit to find it worthwhile. So you brought up this great example of interacting with patients. This is something that if you can make the models with a snap and then have it available for them immediately, you don't have to worry about printing it ahead of time before they show up for their appointment, well, then maybe it's something that we might use more frequently as well. In terms of the different medical specialties, one of the things that I find really exciting about the technology is how it brings people together within a hospital. So our platform has full remote collaboration, which means that multiple people can be in headsets simultaneously, and they're in the shared environment. So imagine instead of us talking over a video chat, you're actually just sitting there beside me, and then we're discussing some 3D model that's in front of us and rotating it, interacting with it that way. So what we find, we do a lot of collaborations with the Ottawa Hospital because that's where the technology was initially developed. And there's a lot going on there that's really exciting, where there was a case recently. It was a pediatric case, and there was a tumor on the ribs in the back, but it involved neurosurgery because it was actually, I think it was a neuroblastoma or one of these tumors like that. And then there was also orthopedics, radiology, and they were all coming together to discuss the case ahead of time and discussing it in virtual reality. And so it's really about like kind of breaking down barriers and providing this really magnificent channel for communication between specialties that might otherwise just see limited interaction.
Yes, very true. So this is a very short time because every doctor is also very, very time bound. They are very busy in their schedules. So here is a possibility with one interaction, everybody can connect. It's also possible, doctor, at far off distances, maybe one person seated in Spain and one in England and one in India. Is that kind of an integration model in the software also available?
Yeah, so we've collaborated with customers in Saudi Arabia, in the UK, basically all over the world. And it's as if you're sitting there right beside them. Like you bring people together immediately. And then actually some of our customers are actually collaborating between institutions. So there's like collaborations going on between like Ohio and Colorado, things like that. It's really interesting.
Well, that's really interesting, doctor. I mean, that's a lot of value, time, especially time, and in terms of attaining the precision required in terms of the solution. So everybody can contribute and make it really happen. Anything that you would want to share otherwise, doctor, when it comes to a very complicated case, probably, as one which you could actually list. I'm sure there could be many, but one complicated case with the technology in terms of what it could actually do.
Yeah, so there's a lot of interest in using the technology. Right now, there's research being done with various people on how it can help look at congenital heart disease. So a lot of these defects that you find in pediatric cardiology cases can be difficult to visualize on images. And in fact, many cardiologists, because they're rare, they don't necessarily even have that great 3D mental model of what it is that they're looking at. So you can create those cases in virtual reality, and then you can have the multiple people there together. And so you can have an expert that's there and teaching other people, okay, this is what this defect normally looks like, and then this is how you would treat it with an implant or device or something like that. So that's one of the cases as well. There's also some interest in doing research with the platform to see if it has benefit to sizing of implants for cardiology cases. So particularly, again, in pediatrics, you often need to use adult-sized implants because they don't have ones that are children-sized. And so being able to create that 3D model of the heart and then import the 3D structure of an implant that you might be using, and then actually using your hands and seeing if it'll fit, maybe cutting away part of the heart to see if it's overlapping various features. That's something that there's some real potential benefit there.
Doctor, one more thing, penetration that it has actually got globally now. In which countries are you very active, and how do you work on a business model? Are you looking at resellers in different countries for you to partner with them and then propagate the technology and then work on a distribution model, or how does it work?
Yeah, so as a company, we're focused our efforts on North America just because that's where we are. I'm sure you've experienced virtual reality, so you understand that experiencing it as something where the headset's on your head is much different than seeing it on the screen. And so when it comes to promoting the benefit of the technology and educating people on how it can help, it really benefits us to be able to be there in person. And so that's one of the reasons why we're focused on North America. That said, we do have a lot of interest in partners across the world. We have conversations going on in that sense as well. And then we also have customers globally. So we're not, even though we're focused on North America, we're open to all opportunities.
So the reason why I'm saying this is since we're actually working as a consortium, the many respondents who are resellers for different products, all 3D products, maybe scanners or 3D printers, 3D visualization can also be a part of their portfolio for them
Absolutely.
to go out and share it with, because it is complete 3D technology solutions. And we also help in terms of driving the course because we also have partners registered. This year we've been actively registering all our partners and also promoting these technologies. So I think the larger interest would be to see that how we can also be instrumental in terms of promoting it, and we will see where that dots can be connected to see that how it can translate to business. But the first and the foremost thing is to see that everybody the doctors get an experience of this. So tell me one thing, doctor. So you need to have a handset, or it has to be a headset that you mentioned, and a monitor. What are the various devices, parts to this entire thing in terms of virtually when you want to design and you want to get your visual room ready? What are the things to be ready?
Yeah, so for our platform, it requires a virtual reality headset. So it's something that you wear. It also has to be connected to a computer. So there are mobile headsets out there, but because we do a lot of really heavy computation to generate these 3D models from the images on the fly, then that requires the heavy-duty graphics card in a computer. So basically, a gaming PC, something with a good graphics card, a virtual reality headset, and then just like the normal monitors for a computer.
And NVIDIA is a preferred choice, obviously, for graphics in terms of your graphic card.
Yes, it tends to be the graphics card that everyone uses.
Yeah, so those configurations will all be shared with you by you, and then it can be formulated, right? That's how it is.
Yeah, so we have it on our website what our recommended specifications are. We often get questions where people say, "Oh, would this computer suffice?" And we'll help them make that decision. And if they don't have a computer that is compatible, then we can help them find one.
So if we have to venture this in India, if you can let us know, how we can go ahead and do this, we would be able to also be a catalyst in terms of getting that organized.
That'd be great.
We would definitely want to do that because when we are trying to look at these 3D graphy labs, it needs to be completely an end-to-end in terms of offering solutions for 3D. Maybe the machine, because everything will actually be complementing each other. So it's this is a time that we are actually dealing wherein we want to make the best use of technology. So every technology is going to be benefiting and it is complementing the course because at the end of the day, it is for the final end result in terms of what we want to achieve. That's the intention.
Absolutely. So that's why we've made our platform. It imports structures from other platforms. You can export STLs and OBJs. So we do have people that create 3D prints out of the things that they've done just for the purposes of communication with patients. And so we really want to be like a part of that ecosystem, that 3D ecosystem that you're talking about, where you have all the different options and you basically take the tool out of your tool belt and use the one that's appropriate.
When it comes to even education, that's something which is an area which is every day you have an aspirant set of medical practitioners and doctors who are future ready for accepting new technology to be benefited from this. Obviously, this augmented reality, because the future is this, augmented reality and virtual reality, making it more simplified. So the students today, they are very, very glued and more induced to technologies to make things more easier, because so that efficiency in time and then making right evaluations in their case studies and cases, they want to make much of the better sense using this technology. So institutes, would you be open to signing up with institutes also, doctor, if it has to be in India? Or are you doing it right now? Some of the examples that you're doing it in North America with medical institutes and medical colleges?
Yeah, so actually one of our early customers was a biology professor in Utah. And this is interesting because it shows the broad applicability of the technology. She teaches her anatomy course using the platform. So the students will go in, they'll make 3D models of anatomy. They'll actually have assignments where they're instructed to measure various features and figure out that. But it's actually animal anatomy. So she has these really crazy CT scans of ostriches and Komodo dragons. And so the students are learning that way. It's a really great example of how you can have this like virtual classroom that you're working in together. On top of that, we do have some initiatives that we've started just with small groups here, just getting as prototypes in terms of teaching anatomy for specialized cases. So there was one example that we did recently where we facilitated a cardiology fellow teaching a biomedical engineering course about these heart defects that exist.
One more thing that I'm also seeing an opportunity is, Doctor, certain specialization where 3D printing probably would not be of maybe use, like ophthalmology, when it comes to eyes. So are we looking at getting as minute in terms of the precision that we can obtain from this technology in terms of study? I'm just trying to think overboard in terms of an opportunity. So,
Yeah, so
because nerves...
the precision that you have in the virtual environment is limited only by the imaging that you have, right? So you could actually, the precision that you can create in a virtual environment is basically like the floating point accuracy of how the computer defines numbers, which is incredibly small. And so basically the limiting factor is the resolution and the detail in your image. If you have an image that's high quality, then you can produce as high quality a model in virtual reality to be interacting with.
So thank you so much, Doctor, for your time, and wishing you all the very best in your endeavor. And we will definitely want to see and promote technologies which are really helping mankind, making things more simpler and making things easier. And patient satisfactory index should be the key, is what we strongly believe through these technologies in terms of helping and benefiting the human, mankind. So
Yeah.
thank you so much, Doctor, for your time. And have a wonderful day. Thank you.
Thank you very much. It was a pleasure.